The ocean is the source of all life. People have been blessed with the bounties of the ocean since ancient times. Eating fish was one of these. Demand for fish has grown throughout the world, but it is a limited resource. This has led to the focusing of attention on aquaculture, for which there are great expectations. It realizes stability in quality and supply, and will provide food for the world and prop up Japanese food culture. Aquaculture technology is also expanding into new fields. At Nippon Steel Engineering, we have achieved advanced evolution in large-scale open-water aquaculture systems based on engineering technologies cultivated over more than 100 years. Aquaculture is the foundation on which the future of our food will be based. The large-scale, open-water aquaculture system consists of optimized production management system software, automatic feeding system hardware, and a cage system. It is characterized by the infrastructure developed through technology used in manufacturing to realize highly accurate management based on AI and IoT. The optimized production management system has two purposes. One is to minimize the amount of feed required to fatten fish by 1 kilogram. Feed accounts for 60 to 70% of the cost of aquaculture production. It suppresses waste, which has a major effect on profits. The other purpose is to boost the growth of fish that are farmed for only a limited period of time. Applying our plant operation technology to store and analyze huge volumes of data allows the giving of feed at the optimal time in optimal quantities. This reduces costs while improving profitability. The automatic feeding system relies on pressurized air to transport feed stored in a silo through a submarine pipe to feed the fish in cages. The aging of people and shortage of labor in the fishing industry is currently a problem, but automation and labor saving in the most labor-intensive job of feeding the fish, combined with the use of large cages, can triple productivity. The system also enables the feeding of fish in rough seas, formerly not possible, minimizing the period of hunger and controlling the loss of feed. When pelletized feed becomes crushed or cracked, it ends up being uneaten because the fish fail to recognize it as food. So, we carried out repeated experiments to minimize this, enabling long-distance transportation. This has allowed the setting up of automatic feeding systems not only on platforms near cages, but also on land, depending on the on-site conditions. Having a land-based feeding system means greater safety due to no need for dangerous work out at sea to feed the fish. It also allows stable feeding that isn't affected by the weather and greatly reduces labor. Feeding is done easily on a device, such as a tablet, while monitoring the status of fish through underwater cameras set up around the cage. Large-scale floating cages are able to withstand harsh seas and currents. They remained undamaged, and the fish were safe even in the large typhoons that have hit Japan in recent years. Large-scale floating cages are expected to boost production, but streamlining the landing of fish was an issue. New landing methods were examined, then developed. It has realized a dramatic reduction in the landing time. The environmental impact of aquaculture was evaluated, and the appropriate fish density was estimated, with the cooperation of the Institute of Industrial Science at the University of Tokyo. This is also compatible with Goal 14 of the SDGs, Life Below Water, put forth by the UN. Large-scale, open-water aquaculture systems are set up at offshore locations with relatively fast-flowing water and low densities of fish, making them environmentally friendly systems. The sun rises, and a new day is about to begin again. We fused plant engineering, stemming from steelmaking, with our technology in building offshore infrastructure, lighting the way toward the future of food and the ocean. We are Nippon Steel Engineering.